Welcome to this explainer. Let's dive right into an incredible cosmic voyage, zooming out from the sun all the way to the very edge of our celestial neighborhood. Our solar system is this vast, dynamic, and honestly endlessly fascinating place. Today, we're going to map the whole thing out, step by step, really giving you a sense of the sheer cosmic scale of the place we call home.
Here's our flight itinerary for today. First, origins and the sun. Second, the inner rocky planets. Third, the giant Jovian planets. And finally, debris belts and boundaries.
Section 1, Origins and the Sun. Let's look at exactly how all of this began. Okay, the absolute crucial point here is that our story starts a staggering 4.5 billion years ago. Take just a second to let that enormous number sink in. 4.5 billion. Everything we're going to talk about today, every single rock and massive gas giant, traces its roots all the way back to that deep, ancient past. But what did it actually look like back then? Well, before there were any planets at all, there was just this, a solar nebula. It's kind of wild to picture. Just imagine this massive cloud of interstellar gas and dust collapsing in on itself, turning into a violently chaotic, swirling disk of material. Over countless millennia, that material just kept actively colliding, clumping together, and eventually built the highly ordered world we know today. Now, if we zoom out from that initial nebula, we can actually pinpoint our exact cosmic address. We're located right in the Milky Way galaxy, specifically tucked away within the Orion star cluster. And what's truly amazing is that we're just one of over 500 known solar systems right here in our own galactic backyard. We are literally part of a massive cosmic neighborhood. But check out this ratio. Even though we know of over 500 systems, only 15% of the stars in our entire galaxy actually host planetary systems. The vast majority, a whopping 85%, just sit out there completely alone. To put that into perspective, it really drives home just how totally unique our sun is, anchoring its very own family of planets. Revolving around that unique sun are 8 planets, and as we map them out, you'll see they fundamentally fall into 2 contrasting camps, based entirely on what they're made of. We've got the terrestrial planets, those are the inner rocky bodies, and the Jovian planets, the massive outer giants. Grasping this big divide, that's your ultimate key to understanding the geography of our solar system. Section 2, the inner rocky planets. Let's go meet our closest neighbors. So these 4 interterrestrial planets share some very specific unifying traits. They're primarily composed of rocky material, which means they actually have solid surfaces. You could theoretically walk on them. They're also completely devoid of any ring systems, they have very few moons, if any at all, and compared to the outer giants we'll see later, they're really quite small. Our very first stop on this outward journey is Mercury. It is the absolutely smallest planet in the solar system, and it hugs incredibly close to the sun. Because it's locked so tight to the sun's gravity, it zooms around it unbelievably fast. In fact, its orbit is the absolute shortest in the whole system. A single year on Mercury zips by in only about 3 Earth months. Moving slightly outward, we hit Venus. And wow, Venus is a literal world of fire. Thanks to a suffocating, incredibly heavy atmosphere made almost entirely of carbon dioxide, plus a surface completely scarred by extensive lava flows, it bakes at up to 867 degrees Fahrenheit. It easily takes the crown as the absolute hottest planet in our neighborhood. Now, in incredible contrast, right next door to that toxic world of fire sits a world of water, our Earth. The vast water systems on our planet help create the only known environment in the entire universe capable of sustaining life. It's a delicate, beautiful, life-giving oasis perfectly positioned right in the harshness of space. Finally, we reach the edge of the inner system with Mars, the last terrestrial planet. Mars is deeply, deeply intriguing to scientists. Why? Well, if we rewind the clock about 3.7 billion years, it actually had a moist atmosphere and a watery surface. It's entirely possible that this rocky, red neighbor of ours might have also supported life before turning into the dry desert we observe today. Pretty wild to think about, right? Section 3, the giant Jovian planets. Time to meet the massive outer giants. All right, here we find the Jovians, and the crucial takeaway here is just how utterly different they are from Earth and those inner planets. The contrast is stark. They are completely immense in size. They possess multiple moons, they sport these beautiful ring systems, and fundamentally, they lack any solid surface whatsoever.
Literally, you couldn't land a spaceship on them if you tried.
We can actually break these four outer giants down even further into two distinct subgroups. First up, we have the gas giants, Jupiter and Saturn. These are predominantly huge spheres made up of helium and hydrogen. But further out, we hit the ice giants, Uranus and Neptune. These are fundamentally different because they contain rock, ice, and a freezing liquid mixture of water, methane, and ammonia.
Jupiter kicks off the outer planets, and it reigns supreme as the absolute largest planet in our entire solar system. It is a massive, swirling ball of gas that completely dwarfs everything else in its orbital path, truly the king of the planets.
Next up is Saturn, our second largest planet. Its signature rings have a jaw-dropping scale. I mean, they are impossibly wide, literally wide enough to span the entire distance between the Earth and our moon. Yet, despite being that incredibly broad, they are surprisingly thin, measuring barely a single kilometer thick.
We wrap up the major planets with the ice giants. First, we have the slightly bigger Uranus, which is incredibly famous for literally rotating completely on its side, unlike any other planet we have. And finally, sitting right next to it in the cosmic dark is Neptune, the outermost planet, which, as you might guess, makes it one of the absolute coldest places in our entire system.
Section 4. Debris belts and boundaries. Let's look at the outer edges of our system.
Let's mark our distances as we fly outward from the center through three highly distinct zones of space debris. Step 1 is the inner asteroid belt. Step 2 is the much further outer Kuiper Belt. And step 3 takes us to the absolute edge, the Oort cloud.
First, let's compare those disks. Orbiting right around the terrestrial planets is the asteroid belt. Think of it as a flat disk packed with rocky objects, ranging from microscopic dust particles all the way up to the dwarf planet Ceres. But much, much farther out, orbiting past the Jovian planets, is the Kuiper Belt. Unlike that rocky inner belt, the Kuiper Belt is made almost entirely of icy debris. It gives birth to many of the comets we see, and of course, it's home to the famous dwarf planet Pluto. Finally, we reach our ultimate boundary, the Oort cloud. Way past the Kuiper Belts, space opens up into this vast spherical collection of icy debris that wraps completely around everything we've just discussed. This marks the absolute edge of the solar system. Why? Because it is exactly here where the sun's gravitational and physical influences finally let go. Beyond this, well, there is only deep interstellar space. Seeing how perfectly this highly specific configuration of planets, icy debris, and life-sustaining elements revolves around our star makes it a remarkably special place to call home. But looking out into all that dark leaves us with a pretty profound question. With over 500 known solar systems located just within the Milky Way, is ours truly the only one with this exact, life-giving configuration? Or is there another world out there, perfectly positioned, just waiting to be understood? Thank you so much for taking this cosmic voyage with me on this explainer.